A relation is a set of ordered pairs. A set of ordered pairs. And I'm just going to give you all the definitions at once so we don't have to keep going back and forth. Remember, ordered pairs have parentheses around them. Which always comes first? Brady? Yep, so it's x comma y. The domain of a relation is the set of all inputs. And I'm just going to kind of do this. The input those are the same. Inputs are all the x coordinates in the ordered pairs. Or in the relation. The range is the set of all outputs. You can put these in Notability if you want. You can write right on your iPad. Because we're going to be doing a lot of graphing this chapter. And the output is all the y coordinates. In a relation, in the relation. And then a function is a relation with the property that for each input, what's input again? X. There is exactly one output. What's the output? Y. The vertical line test, I'm just going to draw a picture. If this is my graph with my X and my Y, and it looks like this. Let's just say it looks like that. If you hold your pencil vertically on that graph, what has to be true is it has to pass and it can only hit your pencil in one spot as it's being held vertical. So does it hit in one spot here? Yes? Here? Yes, 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 yes. That's a function. Vertical line test, it's going to hit your pencil in one spot vertically. Well, if I draw linear, okay, this is another one on top of it. I'm not going to redo a graph. See that? Does that pass the vertical line test? Hold your pencil straight up and down on it. Does it hit your pencil in only one spot as you go across? That's a function. What about one like this? That's my coordinate plane. Does that pass the vertical line test? No, because if you hold your pencil straight up and down here and here, there's several points where it hits it in more than one spot, right? So this is no. It's not a function. So let's look at example 1. It says identify the domain and range of the relation, or the relation represented by the table that shows the Norway spruce's trees height at different ages. Okay? So the relation is the set of all ordered pairs. So you just write the ordered pairs down. it's X comma Y. So at 5 years, it's 13 feet. At 10 years, it's 25 feet. At 15 years, it's 34 feet. At 20 years, it's 43. At 25 years, it's 52 feet. So for the domain, it's just all of the X values. If they are ever duplicated, you don't have to write the duplicate number. Okay, so for the domain, it would be the set, well, you have 5 in the X, right? That's an input. There's 10, there's 15, there's 20, and there's 25. The domain is just all the set of X's. Okay, so the range are all the outputs, which are the set of all the Y's. So, what are my Y's? Christian? So those are all your range values. Okay, it's all the Y's. Okay? When you represent them as a graph, you just plot the ordered pairs. So go ahead on that graph that I gave you in your notes, plot the ordered pairs. Does everybody agree that's where they are plotted? Okay? Well, then we have to draw what's called a mapping. And can you guys look at the graph and tell me, is it a function or isn't it? This is not going to be a function because it fails right here, doesn't it, on your vertical line test? So this is not a function. Okay, and I will tell you, how do you know if you don't graph it? Look at your set of ordered pairs. Do you have any duplicated X coordinates? Jackson?
One.
You have one that's duplicated here. 1 there and a 1 there, and it is going to 2 different Y values. That right there is a clear indication that it is not a function. Now a mapping, what we do is we put all of our inputs in the first oval. Okay, so I'm going to put them -3, -2, 1, and I'm not going to duplicate the 1 and then 2. All the outputs go in the second one. So I've got a 2, a -2, a 1, a 3, and a -3. So what we do is -3 was mapped to 2, so I draw an arrow to it. -2 is mapped to -2. Draw an arrow to it. 1 is mapped to 1. But 1 is also mapped to 3, isn't it? Right there in a mapping, you should know it's not a function because you cannot have 1 going to 2 different Y's. And then 2 maps to -3. Mapping, it cannot be a function because the 1 goes to 1 and it goes to 3, so they are not functions.
-5, -3, -1, 2, 5.
And the range?
2, -1, 0, 3, 4.
Everybody agree? Now I do have to tell you, if the Y's are duplicated, that's okay. The X's are the only one that can't have the same X going to 2 different Y's. Is number 1 a function? Yeah, it is a function. So the domain there, and then what's the range?
-3, 2, 0, -1, 3, 1, and -2.
Everybody agree? Is this a function? It's not a function. Why not? Jackson? That's right. There's 2 3s that duplicate. There's 1 here and there's 1 there. So it is not a function. Okay, and then using the vertical line test, in example 4, tell me, is it a function? Does it hit your pencil vertically in only one spot? If it hits it only in one spot, it's a function. What do you guys think on A? So yes, this is a function because it only hits your pencil in one place going vertically. And if you look at the second one, they kind of drew the vertical line in there for you, didn't they? See how it hits here and it hits here? Is that a function? Not a function. It did not pass the vertical line test.